let's talk about what is quality, then briefly look at customer and regulatory requirements. And I know that a lot of people, they focus on the printing process requirements. Actually, the MDR does not apply to devices that were manufactured in hospitals, providing that a list of around 8 conditions are met. Show them proof of training. You have to be able to show measurements. If you're saying you're doing measurements, if you say you're doing income checks on the material that you use, show proof of that. Also, CAPAs and feedback are. Maybe you mentioned you noticed the word appropriate. So it speaks about manufacturing and use of devices occur under appropriate quality management systems. So you can wonder, and the FDA has even proposed to adopt ISO 13485, so to harmonize them, so there will be even more similarities, I would say. So you need a digital document management system for that. Paper really can't be controlled, but it doesn't need to be an expensive system. I use a wiki system to build a QMS for my customers. And I've shown here a little workflow all the way from imaging to design to pre-processing to 3D printing, post-processing, testing, and final release of your part. And especially in resin printing, those can be a source of uncured resin down the road. Location in the build is even important. Printers usually print more accurate in the center. I think additive manufacturing is quite a unique process in that sense that warping, shrinking can happen when you polymerize large areas, but also the quality of your light source, it can fade, it can lose power, so your polymerization rate goes down. In post-processing, you have to remove supports. If you don't remove enough, if you cleaned off. Also here, you're probably using a UV oven to cure the parts. What if you have a light source failure? Using a certified material is not enough. It only tells you that under the perfect conditions, you can make biocompatible parts. So do check the disclaimer of your material supplier. But do you get a certificate of analysis with every batch of material? How do you store the parts? This risk of all, which is people. Are they properly trained? Does the engineer know what to do, what to look for? Even to have patient safety, consistency and reliability, efficiency, but also cost saving, and you name it. So a lot of people are wondering how to start with a quality management system. My suggestion would be, and this is also how I started, read the ISO standard. And probably you have to read it a few times, didn't document it. Analyze your risks, mitigate your risk, be aware of the regulatory requirements, but also read guidance documents. And there's a lot of interesting guidance out there that helps you. I think that's also should also be part if you're in the back of your mind.
Works I need to do.
Yeah, well, basically, I've seen that most point of care facilities are quite small teams. So usually it's
Right.
It's 2 engineers or so have to do the bulk of the work. So yeah, it's usually it's mainly about documenting everything properly. But once you have the system set up and you document it the way you work, someone new comes in. But then it's all about indeed recording and making sure that everything you have done is properly documented. You need software to go around it. You probably need compressed air. So the whole setup of the lab it goes beyond just the machine.
Wish I have talked to you earlier.
Well, I said they're pretty accurate. So I think in terms of accuracy, you're good to go.
We launched this in 2020 and we're collaborating with Mayo Clinic. Procedure times. And that's because the current surgical planning is time prohibitive. As you see here, the steps within current virtual surgical planning, there's about 6 steps: taking a CT scan, sending that to the vendor for virtual surgical planning, to the surgeon, so then they can pre-bend that plate and produce a customized solution to the patient. Our tools plan cases on your own without relying on a biomedical engineer. And not that biomedical engineers don't have a place in this, they absolutely are a critical component of this process. But what we're allowing is for surgeons to take control and for the physician to take control.
Yeah, go ahead.
The segmentation itself takes about 30 seconds, but the planning process takes about 5 minutes.
I see. And what about the surgical guides? Because I saw one of the pictures you have arrangement.
Yeah, the trauma solution is completely point of care based. And
what about the models?
yeah, so we're agnostic, and we're a agnostic company that.
Well,
yes.
okay, got it. And then we have another question. Hey guys, please put in the Q&A box so I can keep track, because it's kind of hard. We have another question from Ash. Which AI tool do you use for segmentation? Are you allowed to tell people? Is this a proprietary?
Yeah, that's
awesome. Okay, so Shannon Walters and Chris Lita Castillo are from the 3D quantitative lab at Stanford Healthcare, and I've known both guys for many years. And
a pleasure to be here. Chris, you want to share the slides? We're going to be sharing a presentation. But beyond 3D printing, we provide about 150 other 3D type services for advanced visualization and tumor response assessment. And we use lots of different software, lots of different printers, and we have lots of people with lots of experience. And more recently, we've gotten involved with clinical AI, and that's what's been keeping me busy. And at the same time, they've asked us to expand into the AR and VR space and support.
Only the MR selected. The extended reality model that you can see in the lower right-hand corner of the screen includes MR for tumor visualization that has also been segmented in green, and CT for vascular and bony anatomy visualization. Now, onto the differences between 3D printing and extended reality. One strength of extended reality is the increased utility of segmentation, meaning that you can do more with your segmented objects, like adjusting opacities and visibility to better understand the relationship between specific objects to worry about. The turnaround time is also shorter relative to 3D printing because it's just the segmentation and display customization time that you have to worry, Here you see a few of our surgeons discussing the surgical plan using the paraspinal tumor model featured earlier in this presentation. He used the extended reality software we have at Stanford to review the anatomy and plan the surgery. And then he used the 3D print that we provided to simulate the surgical plan.
So it's amazing to see what they've been able to do, and I'm hoping we can share even more about that in the future, but it's looking great and we're helping them out quite a bit. But that doesn't mean we just started. Here's some examples of some of the other ways we've helped them out with these. We do a fair amount of research too. I've shared this slide here before too. You can see we have primate skulls on one side and aortic connectors are going to be linked into a flow system on the other side, and we've been able to help people get some pretty nice publications from our 3D printing resources. We're going to go fast here, Chris. This is very similar to what Eric showed, the process. In an ideal setting, we're going to figure out how to end all of our processes with payment. And that's not a very common thing with 3D printing just yet. But there's some other ways to get payment than actual reimbursement from research. And I'll go over a few of that just in just a second. The patient, it's not pretty, but it gets the job done. And and a side benefit that I don't have in here is that it's helped us be the largest contributor to the ACR database than the entire country, as far as I'm aware of. I think that about half of a lot of the entries in there were early, and we were able to convert it into a quick way to upload all of our data to the ACR registry. Next. So we use this to track a number of things, like who's our biggest requester, what types, what kind of anatomy was in it, how much material cost did we have, what was the cost of our materials.
So right now, at least for us, there isn't really a competition between the two. Right now for us,
Models and stuff like that. What do you guys use for measurements?
Have the expertise on within the software to give them a lot of those measurements ourselves. So at Stanford, that's one of the avenues we have not explored, which is.
That's why we have this webinar. Awesome. We have another question from the audience. When models are provided, are you obtaining surgeon or patient feedback?
somewhere where we should be spending our time, but we haven't kept that up.
My plug here. All right, so let's move on to our final speaker so that we can stay in time. Thank you so much, Shannon and Chris, for a fantastic, wonderful presentation again. So Rodrigo, Dr. Salazar Gamara, Rodrigo, I call him, he is the co-founder and CEO of M3D.
And among these 21 nations with world-class economic poles, we have a lot of inequity. And I strongly recommend you passing some life-changing experiences down here or up here outlets. So this chance of being integrated, all the technological protocols, and basically up to the point of care 3D labs with of the success. And from the perspective of our nonprofit organization, we are convinced that the point of care, the key part of the role of the decision making jointly with the surgeons. So an optimizing quality of life for our patients is having definitely a team. So this experience from Chile was spread to Peru, in which also we have the chance to achieve functionally, and this joint effort of different specializations allowed us to reduce up to 2 years of the final rehabilitation restorations of the patient, specifically for placing the implants to support and retain the prosthesis. But then in 3 days, we rehabilitate all these patients to provide the best we could do on the conditions we had.
Yeah, give us an idea how much you need and what do you need for each of these cases that you presented?
The machines are like, oh, give me time, we need more resin, we need more machinery, more effective area to print and things. So fundraising, it's always important because the most important resource, it's always human challenge. Mm-hmm. But it's kind of fun. It's like you have to be every time we have to have an infrastructure, like 14 people working at the same time. So it's kind of a small hospital to deal with this.
Awesome. So we're approaching the end of the event here in timing. So I want to invite all the panelists to join us on stage, and I'm going to continue this QA process. So a follow-up question for you, Rodrigo. I want you to answer this first, and all the other speakers can also chime in, is how do you coordinate with the surgeons pre-operatively for their pre-operative planning?
At beginning, could be a lot of talking, but once you get used to what the other have in mind, so when you understand the other need, it's very easy. So everyone knows, and with the spirit of being working together, there's no ego. We haven't, there's no ego team in our side.
Our side, we found that they want to set it and forget it kind of situation. So, with the exception of the congenital hearts and a few of the other things, other studies that they do. So I don't think we're a normal use case, but that's how it panned out here at Stanford. So a lot of the prints we do not require that much surgeon involvement. And when they do, we typically allow them to interface with the radiologist, and then the radiologist tells us what our requirements are. So we don't have as much direct feedback with the surgeon, and we don't really have time for it either. It's the way that we're structured. So it's a unique, I don't think we're the typical environment though.
What we're going to ask.
Yeah, and I want to build on what Chris is saying, Jenny, is that a lot of the hospitals we're working with, the surgeon is able to, so the segmentation team or the biomedical engineering team or the 3D printing team can produce a model either through a segmentation software like Mimics or some sort of software and import it into immersive touch. And then the surgeon is able to view that segmentation and be able to make edits. Yeah, I mean, I think somebody asked whether we sterilize at the point of care or
Yeah.
beforehand, and we definitely do that. And I think the device reps, we work with partners like Zimmer Biomet and some other device partners that also handle some of these things at the point of care.
Yeah, indeed. I mean, you guys have a lot more challenges. By the way, if you want to fundraise for that nonprofit, feel free to put the link in here.